Good afternoon, ladies and gentlemen. Thank you for this opportunity, sir, for conducting this talk. I going to talk about the main two concepts in the MUMT, but before we go to the concepts part, we need to first understand that why there is a this teaming and why how you achieve this teaming. The problem statement what military aviators have faced over last few decades is the rapid evolution in the A2AD weapons which has happened, and also the kind of technology which has come onto the jet, the kind of sensors which are able to provide you the information at the drop of the hat, and thereafter scanning through that information, using that information in a fuse picture somewhere, it takes a big toll on the human cognitive abilities. After two grinds in a BVR combat with the kind of adversaries you have, you find that there is a definite amount of loss of essay which takes place in the cockpit. Also, the manned fighters, with the advent of these super special technologies on board, has become very costly, and loss of a manned fighter is actually a setback to any air force in the world. There are missions which are very high risk, and high risk missions has a multiple drawbacks in case these manned fighters get shot. Also, the technology is expanded in a manner that now you have a very high processing ability available on board a very small drone or an unmanned plane, which requires not so much amount of power, and there is a cloud which can work on board in a network while in the air. So all these things have led us to MUMT. This is a coordinated operation of manned and unmanned airplanes working together in a team with a common objective, wherein the man takes the edge and takes all kinetic decisions, while the unmanned extends the reach, uses the sensors, and absorbs the risk to the manned fighter. This works on a framework to work as a team in the air, dynamically flying at high speeds. You need reliable and resilient links which provide you control, share sensor data, retask in case required, and in case if your few of the drones are either too far or get shot, there is a graceful degradation which takes place in the link. So you never lose the entire picture of the network. Also, the LPI and LPD, we shall come to that later. There are certain techniques which are utilized to make them more resilient. Also, you need a very trusted autonomy on these birds. They have to understand and execute the commander's intent, which is very important. These birds need to be modular, bird as a module in the team, and the payload on the bird should be modular so that you can reconfigure the bird to take on a different mission at different time. A very good HMI which should be intuitive, adaptable, and should be fast, and should aid decision making of the manned fighter. And you cover this under the umbrella of doctrine, wherein you employ them correctly and then develop the tactics from these technologies. An overview of the world over MUMT program with different names is flashed on the slide. You can call it Loyal Wingman, an ATS, or a optionally manned, or a drone wingman, remote carriers with the 6th gen, or the collaborative combat aircraft which are under development in the United States of America. Before we start with the teaming, it's very important to understand the level of interoperability and what are these levels defined. As per the standard agreement of NATO 4586, there are 5 LOIs which are given on the slide. First is what we had earlier, that the fighter can receive the data from the UAV through the ground control station, so the information comes to you indirectly. LOI 2 moves on to the direct receipt of the sensor data to the manned fighter. With 3, you start getting the control of the UV payload. You can steer it, use it as you need it, but still you are not able to control the UAV in the air. LI 4 is wherein you get some level of mission control on the autonomous bird, wherein you can make its flight path, let it fly some route, and do the mission as you want while using the sensors on board. And LOI 5 finally comes to the complete control of the UAV and the payloads, which for a fighter aircraft as of now is very limited, and the work is underway with a lot of limitations. Coming to the concept of the loyal wingman is, you need to imagine this bird as a very obedient wingman who flies alongside you, flies ahead of you, takes on the task of combat, reduces your workload by seeking, by sensing, contesting the airspace which you are trying to control, and employ those weapons which are required to gain control. By doing these actions, it becomes a force multiplier, and this team itself mitigate the risks for the manned fighter which is there. In the next slide, we'll understand it slightly better. In a CAP mission, if you see, in the classic sense, it used to be a group of 2 to 4 fighters controlling a swath. Depending upon the kind of BVR they have, the kind of sensors they have on board, they used to control a given amount of area to defend the VAVPs which they had. Now in the same box, if you put a team of manned and unmanned, you realize the manned fighter becomes a mini C2 node in the back, while these unmanned ones fly ahead. As per your mission task, the way you have programmed the mission, they undertake them with certain autonomy. Sometimes you change those decisions in the air depending upon the tactical situation and the input from the mission command. And these wingmen extend the patrol edge, probe the threats, jam and evade, and carry your extra missiles if required, extending your range, and create a very layered intercept geometry for you to achieve the mission objectives. That's how your CAP with this teaming takes place. Certain building blocks for this team to succeed starts with that secured communication architecture, need to have a very high bandwidth and should be resilient to the EW of the adversary. You need to have the minimum latency available on the network and a very potent use of the software defined radios. The data and the stack of the AI on top of these radios actually does a good amount of work. The only issue which you fight with is the speed and the loss in data which happens. The teaming architecture is how you define a team, who controls who and to what extent, and who feeds who and to what extent, and how that sensor which is being on board any of the machine gets picks up the data, and that data gets filtered, the intelligent information is gleaned and then given to the right amount of person in the team who can take on the mission thereafter. And that's where the LOIs come into play. On top of that works the AI and the autonomy, which actually takes the load of the manned fighter, and through the behavioral autonomy and the edge processing at the edge, you realize that the workload of the pilot reduces and the achievement of mission objectives become very fast. The mission control and coordination happens through the unified HMIs, and a distributed command and control sits in the cloud, and with a good amount of MCON you can actually give a surprise in a given area, and before anybody comes to know, you are there on the target. The OODA loop in these is very important. It need not to flow back. You need not to flow back to the mission commander to take certain decisions. The decision gets taken at the right on the edge. With a resilient communication architecture, I'll just add prepared this slide with slightly more scientific details. LPI and LPD of a network, primarily the difference is that in the interception part, the adversary knows that there is a signal, but it is difficult for him to get the information out of that signal. In the LPD, you hide that signal from the adversary. So the LPI happens through the multiple techniques. You change your frequency at certain hop rates. The LPD happens through other means, that you have directional antennas working on board a bird. They transmit only in a given direction, so that the other side you are not even aware that there is a signal which exists. Also the broad spectrum sensing which takes place in the LPD part is another technique which is under works right now. The mesh networking, or the MANET, which is the mobile ad hoc network, it is like a self-informing and self-healing mesh. You get airborne, there is no one controller there. The network identifies itself, the other radio links up to it. Whenever you are in the range, when you move out, automatically you are outside the network. And in case any of your birds are taken out or due to endurance have gone back, automatically it heals itself and the task gets redistributed. The cyber resilience, this network needs to be cyberly resilient and secure. A lot of architectures are in the works with the zero trust, which verifies each and every command which it gives and receives. And a real-time authentication takes place in the background, with obviously adds certain time limitations to it. The teaming architecture has clouds in 3 layers primarily. So one is at the top, which sits with the man platform, which is actually the mini C2 node. These are low of the roll high processing clouds, and human is always in the loop. In the CCAs, which are your forward edge, which carry the slightly expensive sensors and which are not attritable. These are high maneuverability unmanned aircraft which carry your sensors to sense and has active radar at times. The arsenal CCAs are either launched by the manned fighters or launched separately or through the attributable CCAs in the forward edge, which work maybe in a swarm or maybe independently, and they carry the weapon or they themselves are the weapon which are used to hit the targets and achieve your objectives. For the autonomy and AI framework, in terms of AI, there is a decentralized AI agent. The health of all machines get evaluated at each step, and based on certain parameters which you define as a designer of the autonomy, these decisions are taken on the go by these birds. The mission, selection of a mission and the objective, it can be changed at the drop of the hat, and it generally done through the AI automatically. Also, there are pre-programmed logic you can define to these birds, and they can take on that task. If they are not able to achieve, they come back to their pre-programmed fallback mode and thereafter maintain position with the manned fighter. The ATR, which happens through the edge processing, wherein you process the data right at the edge. So, a lot of CVML and techniques come into play. Data of data is analyzed there, and only the information what you need comes back to you, which avoids the information overload in the manned cockpit. These autonomies can be scaled, adjustable, depends upon the stack you're running on top of each other. And the veto power generally lies with the human in the loop at all times. The mission control and coordination takes place from the manned fighter or AVAX maybe, or a ground control station if possible, if within line of sight. There are multiple ways that this HMI becomes more intuitive through voice command. There are LLMs available now, very adaptive, and the command and control remains distributed. So even if you lose a few birds here and there, still your C2 will continue to run seamlessly. Only thing is that you will need to employ more birds thereafter later. On the autonomy part, there are 3 kind of autonomy which run on top of each other. We'll start from the bottom, which is the teaming, which actually is the umbrella autonomy on top of the team, which decides that who goes to fly what and where. The tactical autonomy runs at the unmanned level, wherein the mission allocation takes place and the mission allocation also changes hands in the air. The vehicle autonomy is more to do with the vehicles flying. Depending upon the mission, the vehicle can choose to choose a path to fly, choose a flight path. It can decide a path based on the kind of threat it is facing. So it is free to take care of its own flying part, and the autonomy given to each bird in the team that ways. So with this we conclude it. The teaming between a man and unmanned is something which on a fighter works as of now. On slow movers, it has been proven up to LOI 4. As and when it comes on board these 5th and 6th generation fighters, you will find that is going to change the way the wars are fought, the missions are executed. It gives you a very good amount of situational awareness to the manned cockpit, ensure that it survives, and lets you achieve an early control of air. With this, I thank you for listening. Thank you very much.